So yeah, this talk is about JBoss security, penetration, protection, and patching, and I'm going to go through it in that order. First, I'll just tell you a little bit about me and what I do. I work for Red Hat Security Response Team, and I'm the security response engineer responsible for JBoss products. Yes, there's only one of us, but we're hiring for a second one, so say hi if you're interested. I'm going to go through all of these topics, and I'll just get stuck into it with some background on JBoss. JBoss was originally developed under the slogan professional open source, and it was its own company, and they used a commercial open source model where they developed the software as open source and then they sold it to their customers. And the stuff they produced was the core J2EE server, which is marketed and shipped now as JBoss Enterprise Application Platform, and it's based on JBoss Application Server. Then we have all of these other products that layer on top of it. So you get EAP, and that's all the core bits, and then they add what are essentially deployed apps, and you get SOAP, BRMS, Portal, and then the reverse is web server or web platform where it's stripped down. JBoss was acquired by Red Hat in 2006 and has been fully integrated into the company now. So the key point to note is that this talk is really about Red Hat's commercial JBoss products, not the upstream community stuff. JBoss AS, actually, when JBoss was an independent company, they didn't have two separate streams. They'd make JBoss AS version 3, and they'd give it away to the community, and they'd also sell support for that. Whereas what happens now, since Red Hat acquired it, is we have the upstream version and then we have a productized downstream version, and they're separate code. So here's the architecture of JBoss. I don't possibly need to explain it. It's really simple. That's actually why I use this slide, because it was the simplest slide of JBoss architecture that I could find that anybody had drawn, and that sort of makes the point for you. There's all kinds of stuff in there. But the most important stuff is what you see at the bottom. There's the JVM, and then running on top of that, you have the JBoss microcontainer, JBoss Web, which is based on Tomcat. It's just a refactored version of Apache Tomcat, and then JBoss messaging. And on top of that, you have all sorts of different components that most people use about 5% of for their different applications. So the point of this slide is just to say that there is heaps of different code, and that when you ship a product, it's got all of this stuff in it. It's got the entity manager. It's got JBoss rules in it if it's BRMS or SOA. But very few people are actually using all these features. So from a security perspective, you've got a lot of stuff in there that you need to worry about patching. So yeah, as I said, the key elements of the architecture are JBoss Web, which is based on Tomcat. So all of the actual HTTP interaction and serving of servlets is done by JBoss Web. Another critical component, at least from a security perspective, are the administration consoles, JMX console and web console. And these were sort of relatively small sysadmin apps that allow you to manage things in the system. But they turn out, the top two lines there, JBoss Web and the admin consoles, turn out to be something like 60 or 70% of the attack surface of the whole system. So there's a lot of issues, including the JBoss worm, which we'll cover today, which actually come from JMX console and web console. Like I said, the core that's in all of the layered products is EAP, which is based on JBoss AS. So that's just the application server itself, and then the layered products like SOA, Service-Oriented Architecture, BRMS, Business Rules Management System. They deploy apps on top of that run those things. Okay. So to understand the JMX console, first you need to understand JMX. JMX is the Java Management Extensions, and it's a framework for managing and monitoring systems via MBeans. What that means is you have these MBeans, which are like business logic classes, business logic objects, and they're managed beans. M is for managed beans, and they sit inside the server, and they have this sort of instrumentation layer called JMX sitting on top of it. And JMX allows you to invoke methods on these MBeans. The architecture of it is you have a probe, an agent, and a remote management layer. And the important thing here is that the JMX console is an implementation of the remote management layer. So what it lets you do is go down into the managed beans and invoke methods, set property values, and so on to object instances inside the app server. So from a security perspective, if you can do that, you can effectively execute arbitrary code. Because a lot of managed beans they'll inherit from some Java class, which allows you to do some reflection, which allows you to instantiate an instance of the JVM, which allows you to... So if you can use the JMX console, you can effectively execute remote code. Oh, what happened there? Sorry about that. Okay, yeah, so the JMX console is a web-based JMX management interface. There's various JMX management interfaces, but the JMX console is just a HTTP web app. And like I said, it allows the user to invoke methods on MBeans via a web interface. It's included in all the products, basically. Everything except, I think, Enterprise Web Server. But all of the products, EAP and the ones that build on it, they all have JMX in it. So if we have a flaw there, it affects a huge number of supported products, and it's one of the major attack surfaces. So just wanted to cover that because I'm going to go through a bunch of historical vulnerabilities that illustrate the problem space here, because it's not like there is an archetypical JBoss flaw. There's not one flaw you say, oh, that's the kind of flaw that we always find in JBoss. But the one flaw that we do always find in JBoss is ones relating to the JMX console. So I thought if you needed to understand one thing, it's that. But armed with that knowledge, everybody should be able to understand all of these vulnerabilities. So the first one, and probably the most up-to-the-minute one, is CVE 2010-0738, which is what the JBoss worm that's recently been circulating exploited. This is actually a very simple flaw. You had the JMX console being shipped with EAP and all these other products, and in the relevant web.xml file, you have a security constraint, and the security constraint says you need to authenticate in order to access the JMX console. But it uses these HTTP method tags to say which methods require authentication, because everything's just get and post, right? So some smart developer decided we'll just specify that explicitly. But the result is that if you specify verbs explicitly like that in web.xml, then other verbs don't get any authentication. They just default to open. So in this case, the issue was that you could do a head, and in the JMX console, if you ran a head, what it would do is actually execute the code to run a get and then not return the body. It would just discard the body and give you the head. But if making a get request against the JMX console would actually do something, then that action would take place, and you wouldn't require any authentication to do it. So what people were able to do was, as I said, you can execute remote code by reflecting stuff inside MBeans. So people could make a head request that would do that, and then they could just remote, unauthenticated deploy code, remote code execution. So this was a serious issue, and as you note from the CVE ID, it was found in 2010 and it was patched in 2010. This was another, these are all relatively serious ones that I'm going through here. This was another, I think this one was actually rated as critical from 2010. And this was not a JBoss specific bug, really, but it had sort of impacts for JBoss. And this was the double.parse_double in the JRE. Apparently there were certain numbers, certain floating point numbers, that when you tried to convert them to a double, it would get into an infinite loop. Something that I don't completely understand about how parse_double in the JRE uses. So you give it a string for this number and say, turn that into a double, and it would actually get into an infinite loop, and you could use this to affect the denial of service attack. It was found in the JRE, in the JVM, I think it was 5 or 6 years ago, and only recently did somebody patch it in 2010. Obviously, JBoss is affected by virtue of the fact that it runs on Java, so you want to patch the instance of Java. But there was a secondary effect here where if you had HTTP headers coming in, the Q header, which is the quality of service header, JBoss Web would run that through parse_double to try and translate the string representation into a double for the QoS header. So anybody could remote DOS your JBoss server by just attaching a QoS header value, which is one of the strings that causes the infinite loop. This was the first issue actually that I dealt with when I started working on this in April. My first day on this job was April Fool's Day. And we got this one. And, okay, so Seam is to put it simply, it's just a web application development framework that we use. And the whole architecture of JBoss is that everything is modular and everything is replaceable. There is not the development framework. There is not the web services component. Everything is interchangeable and standards-based to the point where it's a complete clusterfuck, because you can't just say, oh, that's implemented by that. Well, that could be implemented by that, or it could be implemented by that, depending on what people are using. But anyway, that's an aside. So Seam is a development framework. What this flaw allowed an attacker to do was, using expression language, which is part of the web application development framework, they could include calls to .class and .getClass. The expression language is supposed to allow you to pass the value as like a query parameter, and it retrieves properties on the object or something like that, but it's restricted in what it can do. It's implemented as a blacklist, not a whitelist, saying a blacklist saying you can't access this method, you can't access that method. But what you could do was access .class and .getClass, and once you'd done that, then you could instantiate an instance of the JVM. So then you could execute arbitrary code. So you could, just by passing the appropriate get parameter to an application that was running Seam, tell it to execute arbitrary Java code in the context of the JBoss JVM. So what happened was, there's two CVE IDs here, because we had 2011 1484 where we fixed .getClass, the method, but we didn't fix .class, the property, which .getClass is actually just an accessor for. And so then we had to get a whole new CVE ID and release a separate patch. But yeah, the good news story here is that both these were handled under embargo, and there was never any live 0-day for either of them. So, CVE 2011-1483, yeah, this one was interesting. This is one that we actually discovered internally. The role of the security response team is really mostly reactive. Our job is to be the eyes and ears of the world, saying, what's happening in the world of JBoss security, what flaws are known, do they affect our products, and how are we going to patch them, and what's the priority to patch them. But if we have any time, we'd like to try and find our own issues. So this was a case where my predecessor in the job, Mark Schoenefeld, he had some time to pen test JBoss WS, and he found this issue. Basically, all it was a recursive entity attack. You could, if you put recursive entities inside DTDs in a SOAP packet, or any XML web services packet, then one of the implementations of the web services framework would go into an infinite loop and consume all of your CPU. But this is the interesting thing, because everything's modular, there's actually two different web services frameworks, JBoss WS Native and JBoss WS CXF, which is the Apache version, and only the native version had the flaw. So in determining whether or not a customer was impacted by this, you had to figure out, are you using JBoss WS? Do you have web services deployed, or are you using CXF instead? Because it's actually not affected. The interesting one about this was, we were originally rating it as something like a moderate flaw, because we said, well, you can make it consume all this CPU time, but it eventually stops. It eventually returns control, and everything turns back to normal. So it's not a complete denial of service. But what we found was that the payload packet was actually quite small. It was, I think, under a meg. So if you sent a number of requests which was equal to the maximum number of connections that JBoss is configured to, concurrent connections that it's configured to handle, which is something like 4,000. So if you can send 4,000 meg worth of these requests simultaneously enough, within a half-hour window or so, then it will consume all the available connections in the pool, And when JBoss gets a new HTTP request, it will say I've exceeded the number of connections that I'm allowed, and it dies. It actually terminates. So you could use this to affect a complete DOS. So that was sort of a secondary effect and something that we had to fix as defense in depth. Okay. Yeah, so JBoss Operations Network, that's another product that I didn't mention, there's so many of them, is I don't know if anybody's used Red Hat Network RHN for managing all of your Red Hat Linux machines, and it's a centralized management environment where you can say, oh, this machine needs to get this update, this machine is subscribed to this particular channel of software, and so on, and you can see everything in a centralized view. John is that for JBoss servers, the JBoss Operations Network. So the idea is that if you have an environment with 50 or 100 different JBoss servers, you have a John server to manage them all, but John itself runs on top of JBoss. It's a bundled app on top of JBoss EAP. So this issue was interesting. It was simply that there was a command line interface that allowed you to go in and change administration settings in John, and all it did was check that you authenticated, but the authorization check was not implemented. So it was just a stub. So the permissions weren't actually being checked. So long as you could authenticate to the CLI, if you had, because the idea is you can have multi-level management where one person can only manage a certain part of the data center or certain operations, then yeah, as long as you could authenticate to the CLI, then you're authorized to do anything. So the final one, I'm not going to bore you with just a barrage of vulnerabilities, but what I hope this is illustrating is the diversity of them all, that they're all different issues, and a lot of them are relatively, like from a technical perspective, they're relatively trivial issues. So this one, CVE 2011-2894, this illustrates the problem that we have with packaging. We package so many third-party components into the JBoss products, and a lot of those maintain their own security response upstream. So in this case, Spring, which is actually produced by SpringSource and VMware, is another web application development framework that we support. And so they had some issues in there where applications could deserialize objects. And so the idea is that you have this serialized representation of an object, and it's meant to deserialize. But what you could do was, rather than serializing a particular class, an attacker could serialize something that implements a proxy to a class. And then when it gets deserialized, the proxy would be called. So you could use this to invoke java.lang.runtime using get class, and off you go. And you can execute arbitrary code. So this issue was not our problem to fix, Red Hat's problem to fix, because we just consumed this component from upstream. But we had to monitor that upstream, get the patch, make sure that it was compatible or backported to the version that we ship in particular, and then make async patches and so on. So a lot of the time, even if the issue is already patched, we still have this whole process of getting things fixed. Yeah, so to summarize, it's a wide range of flaws, and there's no one sort of typical JBoss flaw, and they affect all the different components. They affect something like the John CLI, which is very specific to a vertical product, or they can affect something like the Java runtime itself, in the case of the parse double bug. They can affect web components, and what I haven't mentioned here is the number of things like cross-site scripting, cross-site request forgery, information disclosure. There's a lot of those flaws that have been found and fixed, and I didn't want to just bore you with that. So this is about the most exciting day that I've had since I started with Security Response Team, was the day the JBoss worm came out. And I started to trickle in reports from people saying, oh, my JBoss server's been compromised, my JBoss server's been compromised. And at first I didn't believe it, but no, there was a JBoss worm, and it exploited that issue that I talked about right at the start, CVE 2010-0738. This is the one where you can use a head to bypass the fact that it was only applying authentication to get and post. What had happened was somebody had written a Metasploit module for this, and then about a week after somebody wrote a Metasploit module for this issue, somebody wrote a scanner for this issue. So you just, plug in some IP address space, and it will automatically scan for it and do a proof of concept exploitation, deploy a hello world page onto the JBoss server. So within a week of that coming out, somebody weaponized it into the worm that we saw. So what it does is exploit this on a server, install an IRC-based command and control botnet, and then starts executing the scanner on which it was based using random IP blocks. So it just self-propagates. And based on Google searches from the peak of the issue, there was somewhere between 10,000 and 20,000 affected servers, because there was a signature for this where it would deploy a particular application that nobody would have had, so you could search for that particular application string on the exposed JMX console of an infected machine using Google, and you could find them that way. The other thing here, the other interesting thing about this attack, and I think seriously that whoever built it was actually not very sophisticated. They've just taken a scanner that somebody else has wrote and probably a payload that somebody else wrote, mashed it together and made it work. And the interesting side effect was that because it was using this head request stuff, if the JMX console doesn't require authentication at all, then this also works. And if you use JBoss Application Server, the upstream community project, then the default behavior is that there's no authentication applied to anything. So if people are using the upstream version, they don't secure it, they don't configure anything, they just deploy it as is, then they have an unsecured JMX console, meaning no password authentication required. And so a lot of these people started getting infected because, hey, there's no authentication, you can go right ahead. So it really highlighted the fact that we need to get more secure defaults into the upstream project. So I'm working on trying to do that. The other thing that you'll see, besides all of the vulnerabilities that you might find in JBoss itself, are configuration and application weaknesses. So configuration mistakes that the administrator makes or weaknesses in the applications that the user deploys. Like I said, the configuration of authentication on the admin interfaces like JMX console is critical. Correctly applying security constraints when you do that. Default admin passwords, even if you do enable authentication on the JMX console in the sort of simplest possible way, the username and password is admin. So if you get that far as to set it, you should also change it. And then within the applications themselves, I mean, I don't want to make a whole talk about web apps, but all the standard web app vulnerabilities can potentially be there, and we see those in customer deployed apps. In particular, cross-site request forgery seems to be, and there's no sort of good reason why, I guess, other than that the frameworks don't protect against it as some other ones do. But yeah, we've noticed that a lot of people, there's sort of some anti-patterns that are starting to develop where people are not fixing CSRF issues properly in apps deployed to JBoss. So that's the context of the problem. That's the kind of issues that we deal with, and the scope of the software space in which we have to fix them. So now I wanted to sort of change a bit and talk about the security response team, what the security response team does, and our role to address all these issues. Because if the marketing guys had been listening to this talk this far, they'd probably be a bit upset with me. So here's the good news story. The security response team, I mean, I don't need to tell you guys what a security response team does. We are the ones who fix the issues when they're found in the product. That's the process that we go through whenever we get a vulnerability report, and that can either be from upstream, it can be from like a vendor mailing list, it can be from a direct report from a researcher, it can be that we found it internally. As soon as we get that, we triage the issue and we assign severity. The important thing here is assigning severity, because the policy that we have is if you have an important or critical issue, we'll release an asynchronous patch for it. So that will go outside of the release schedule of the product, and we'll just give you an asynchronous patch specifically for that issue. So scoring the severity of the issues is very important. The other thing is that as products get to the end of their life cycle, we start to put them into CI-only mode, where only critical and important vulnerabilities will be addressed at all if you're using a product approaching its end of life. So yeah, the severity scoring is kind of something we have to get right. It's very touchy. Once we've done that, we file bugs to actually get the issue fixed. Engineering produces a patch. Patch gets QE'd, and then we make an errata, so an async patch. So here's where we got this is just JBoss vulnerabilities. This is not all Red Hat vulnerabilities. This is where they came from, and this is a really interesting graph. I took off the whole of Red Hat one, but I wish I hadn't, because it's a very different picture. What you notice is found by Red Hat is actually the main source of issues, and that the other one is coming from other vendors. That would be something like the Spring issue. Research firms, one issue from 2008 to 2011 was reported to us by a professional security researcher. And these are no-notice vulnerabilities. These are ones where we're not given an embargoed report, where somebody just drops it and the exploit is live, the details are live, and we have to patch it immediately. And the main source of these is on a mailing list. It just gets dropped to OSS security or something like that. The interesting thing about this slide, though, is that if you look at it for other Red Hat products, a far smaller proportion of the vulnerabilities are found by Red Hat. And the explanation for this is not that, you know, the one-man JBoss SRT is awesome, because I'm not, but that the code base is unique to Red Hat. If we have Linux vulnerabilities, if there's a vulnerability in libtiff, libpng, something like that, there's so many people in the world who might want to work on finding that and fixing that. Whereas with JBoss, it's really just within Red Hat. So we find a lot of the issues ourselves. So going through each step of the process, like I said, once we've received that report, we have to triage it, and our severity scoring is based on CVSS2. So we use that, and then we have a rough mapping between the CVSS score and the severity rating. And we get a CVE ID, and then we reproduce the issue. Once we've done that, we file bugs, and we produce a patch. It's all boring. This is interesting. Backporting patches. This is the tricky bit. So we have a patch, for example, the Spring issue. They might be running, I don't remember what Spring version numbers are up to, but maybe say the latest head is 3.1.4, and what we ship is 3.1.2. They've written a patch, they've committed it to head. It's probably going to work in 3.1.2, or if it won't, with some minor modification, and we don't want to upgrade to 3.1.4. So we have to backport the patch. And this is what the Red Hat developers do. They'll take the upstream patch and then backport it to the version that we ship with our product. And so the idea here is that we can give you continuity. If you have your application certified or tested against a specific version of a library, we won't just update that component because there's a flaw in it. We'll backport the patch to the version that you're using. So we then have to QE that patch ourselves, because if it's backported, it's different to the upstream one. And we have to find there's no regressions, no performance degradation. And these are all things that we've found. And when it's the old story of if you just fixed it when you wrote the code down to you have to fix it after a worm was released, how much does it cost? So we find if you get to the point of having a patch with serious regressions or performance degradation, it costs a lot of cycles. And then finally, we release an errata. So an errata is, an erratum. Errata is the plural. An erratum is an insertion or modification to a document. It's actually from a publishing term. And this is Red Hat's formal process for releasing an async patch. We say, here's the package that you've been shipped, and here's a modification to that. And what goes with the patch is documentation of the issue, a textual description, and then packaging of the deployable update. So yeah, this just shows you the complexity of running that whole process for several issues. Earlier on, I spoke about that seam issue, where there was the ability to use expression language to inject arbitrary code, and we had the two vectors, .getClass and .class. And so originally, 1484 was .getClass, and that got reported to us in March, and then we fixed it in April. But then we found out in June that there was this incomplete patch, so we had to get a new CV ID, And then in July, we released that patch. So for what was effectively one issue, the work spanned over several months. And the point there is that it's hard. Not that we got it wrong, but that it's actually really hard to do this and to follow this process all the way through. It's very time-consuming. So the final thing I wanted to do was just talk about countermeasures. So all of this, I realize this talk was all a little bit scary, and I'm not giving everybody warm and fuzzies about JBoss, but I actually think it really is a good product if you apply your patches, if you conform to best practice, if you don't publicly expose your management interfaces with no password or passwords like admin. It's not difficult stuff. And so I think the lesson that I got from the JMX console worm, the JBoss worm, was that it's not some complex issue. It's not some highly technical, Windows kernel exploit. It's a very simple issue that was patched a year and a half ago, and people just didn't apply the patch. So as a whole, as a sort of ecosystem, we're still grappling with the issue of, okay, we produced a fix. How do we make sure that people use that fix? And so all of this work is kind of for naught if we can't actually get it into people's hands and make sure they use it. So here's the bit where I justify my existence to the corporate powers that be, is that's the value of the Red Hat subscription. Because if you use the community version, there is no security patching. There is no backporting of security patches. You'll get an update when they feel like committing it to head, and if you update to head. So that's one of the, in my opinion, one of the big value propositions of using the commercial JBoss products is that you get this coverage, and if you do deploy all the updates, you're going to be much more secure. So that was a pretty quick tour through JBoss security. Did anybody have any questions? Yeah.
The JMX forum one, how long did it take you that you saw for the RHN customers to get the fix, or for the fix to be published before it was rolled out, as far as you can tell?
So, I mean, with that one, the fix had been published back in 2010. So we found out about it the day that it sort of dropped and people started getting infected. And all we could really do was a bunch of customer communication, because we already produced a fix for the commercial products. For the upstream products, we'd already had a wiki page up saying you have to secure it in this way. So all we could do was just make louder and firmer messaging. We actually put a little flashy banner in the header of jboss.org that says, "Warning, there's a currently circulating worm. Click here to not get owned," sort of thing. And that was really all we could do. And in one sense, it was quite a positive experience, because we were vindicated in the whole thing. It was like all the media headlines started with, "And a patch was available last year." So, yeah, that was the story. Yes?
JBoss isn't the only applicator that's been vulnerable to a lot of insecure by default type issues. I mean, other rival products have had a lot of issues with default credentials. What is being done with JBoss about secure by default?
That's a really good question. So with the next release, EAP6, which is based on JBoss AS7, this is something we're trying to take really seriously. And we always had, the developers always had the view that security makes it too hard. All this stuff is really complex and hard anyway. It's hard enough to convince developers to use it. And if they have to go and mess around with a config file to configure authentication, they're not going to use it. They're going to go back to PHP or whatever. So, yeah, so the security guys would always sit there and say this is a stupid argument. But that was the argument that's been promulgated. So finally we're overcoming that. And I think something like the JBoss worm could be seen as a good thing, because it gives us the ammunition to overcome that attitude and say, this is what happens if you don't apply secure defaults. So in AS7 there's a concerted effort to do that. And then particularly in EAP6, we're putting in comprehensive CSRF protection for all of the admin consoles, and secure defaults for all the passwords will also go into the upstream, not just the productized version. The other thing is that Red Hat's just starting to build a product security team, and this is all about, like, the security response team is all reactive. There's an issue, let's react to it. Whereas the product security team is all about making the product ship with fewer vulnerabilities. So we're just hiring people onto that team now, and we're going to have at least one person dedicated to doing that for JBoss. Good question. I mean, I don't have a good answer to that, but I guess the probably the honest answer would be competing business priorities, and it maybe takes something like the JBoss Worm for it to become a competing business priority to get that funding. No, no, no.
Come on, mate, security's easy.
Cool.
So, does this mean that if you get new customers after you have developed a patch that's 10 months old or whatever, that when you ship a new version of code to a new customer, they get the secure version?
Oh yeah, of course. All the patches are rolled up into the subsequent versions.
You say of course, but that doesn't always happen.
Okay, well no, that's the process. If that doesn't happen, there's been a mistake. That's the process, that all patches are rolled up into future releases. So there will never be, a fix left behind, no.
Yeah, so like you've got your JBoss operations.
Yeah.
Now, what sort of customers were actually your customers, like Red Hat customers for JBoss products? Were they actually the majority of the ones that were affected by the worm, or was it?
I don't really know, to be honest. I mean, we got a lot of reports, and one of the things that's very difficult when we get these reports, we'll get people emailing us or going onto the jboss.org blog and saying, I got infected. And there's this horrible ambiguity around the world, JBoss, because people say, I'm running JBoss 5.1 GA, and I got attacked. And we're like, well, what does that mean? Is it JBoss AS 5.1? Is it JBoss EAP 5.1? Is it JBoss EPP 5.1? What are you actually running? And everybody just says, I'm running JBoss X. So a lot of the reports that we got just said, I'm running JBoss X and I got, owned by the worm. What should I do about it? And in hindsight, it did seem to be mostly people running the community version that were affected, overwhelmingly. But there is that ambiguity in the language that made it hard for us to just look at a report and say, oh, that one's community, that one's the enterprise version.
I was just thinking, like, if they're using the JBoss operations network,
Well, those people should be. They really should be. I don't think any of those could be affected unless they misconfigured. I mean, of course, not every customer is running JBoss Operations Network, right? There's plenty of people out there who might have 5 JBoss licenses and they just manage each one independently, So, anybody?
If you're running it on Red Hat Enterprise server,
Yep.
you've got a Red Hat subscription, would the patches come down quite extended?
Yeah, so we ship 2 versions of all of these products, nearly all of these products. Some of the more esoteric ones, SOA and BRMS, only ship as a zip file, whereas all the more popular ones, EAP, EWP, they ship as both a zip file and an RPM. So if you're running them on Solaris, Windows, Debian, whatever, you can take the zip file and unpack that. But if you're running it on RHEL, then you just subscribe to the JBoss channel and you get RPMs, and so you'll get your patch as a YUM update, basically.
Hey, so if you followed the NSA's security hardening guidelines for Red Hat, which says that you should disable Red Hat network updates and create a cron job and use YUM update instead, for whatever reason, would you get like these JBoss updates?
If you are subscribed to that channel, so the idea is that when you set up the machine, you buy all the different subscriptions, and there's just the RHEL channel, the base thing. So if you're going to run JBoss on RHEL, you need to pay for a different subscription, and then in the Red Hat Network backend, that machine will be keyed against having a separate subscription, and then, you know what I mean?
Would using the other have the same?
Oh yeah. It's all integrated with. It's exactly the same. It's just another set of RPMs, another repo. Yeah.
We've got time for a few questions.
Yeah.
Spring vulnerability found when someone was researching JBoss, or was it different components used somewhere else?
The Spring vulnerability. No, Spring. That one was upstream. That one was VMware. So we just got their report when they released the patch. We have a bunch of cron jobs that go to all of the security, Tomcat security page, Spring Source security page, Oracle security page, and crawl them daily and look for diffs. And whenever we get a diff, it emails us and somebody looks at it and says, oh, they've released a patch for this. So we got it via that process. The day they released the actual patch for it was the day we found out about it.
So I was thinking, Sylvia spoke yesterday where it's talking about embedded packages. You guys maintain like a database of
The way that we handle that is we have a manifest database of all the JBoss products. It's actually, I built it, it's an open source project. You can get it, it's called JBoss Manifest. And what it does is it takes the zip file for any JBoss, well, it'll take any zip file, and recursively unpacks all the jars, because all the jars are zip files. And so it recursively unpacks them, gets their meta-inf/manifest.mf in the jar file, which gives you information about the vendor, the version, what it is. And then it turns that into an SQLite database and a sort of CSV type text thing. And we keep the latest version of the CSV type text thing in source control, and everybody looks at it. So as soon as we get a report of a vulnerability, we go and grep that text file and say, what product has this component, down to the level of the jar file. Yeah. Okay, thanks everybody.